Welcome to our channel, Biography Zone. Today, we are diving into the life of one of the most influential scientists in history, often referred to as the father of modern chemistry, Antoine-Laurent Lavoisier. This video will take you through his fascinating journey, his groundbreaking discoveries, and his enduring legacy in the world of science. Antoine-Laurent Lavoisier, the father of modern chemistry. Early life and education. Antoine-Laurent Lavoisier was born on August 26, 1743, in Paris, France. He came from a wealthy and influential family, which allowed him to receive an excellent education. Lavoisier attended the Collège d'Arrosage des Water Nations, also known as the Collège d'Arrosage Mazarin, where he studied chemistry, botany, astronomy, and mathematics. He excelled in his studies and showed an early interest in science, particularly chemistry. Early career and marriage. After completing his education, Lavoisier decided to pursue a career in law to satisfy his family's expectations. He earned his law degree in 1764 but continued to pursue his passion for science in his spare time. His interest in scientific research grew stronger, and he began attending lectures at the Royal Garden of Medicinal Plants, Jardin des Plantes, which was the center of scientific learning in Paris. In 1768, Lavoisier purchased a position as a tax collector in the firm G.A. Copyright N.A. Copyright Trail, a private company that collected taxes for the crown. This position provided him with financial stability, allowing him to fund his scientific experiments. That same year, he married Marie-Anne Pierret-Pauls, who would later become his scientific collaborator and an important figure in his work. Marie-Anne was not only supportive of her husband's work but also contributed significantly by translating English scientific texts into French and illustrating his experiments. Scientific contributions and discoveries. Lavoisier's contributions to chemistry are vast and transformative. Here are some of his most significant achievements. Law of conservation of mass. One of Lavoisier's most important contributions is the law of conservation of mass, which states that mass is neither created nor destroyed in a chemical reaction. This principle laid the foundation for modern chemistry and helped to debunk the phlogiston theory, which was the prevailing theory of combustion at the time. Lavoisier conducted numerous experiments to demonstrate that the mass of reactants in a chemical reaction is equal to the mass of the products, proving that matter is conserved. Identification and naming of elements. Lavoisier was instrumental in identifying and naming several chemical elements. He compiled a list of 33 elements, distinguishing between metals and non-metals, and provided a systematic method for naming chemical compounds. This work was published in his book Copyright de nomenclature chimique, Method of Chemical Nomenclature, in 1787, which he co-authored with other prominent chemists of the time. This systematic approach to naming elements and compounds is still in use today. Combustion and respiration. Lavoisier conducted groundbreaking research on the nature of combustion and respiration. He discovered that oxygen is a key component in both processes and that it combines with other elements during combustion and respiration to form new compounds. This discovery was crucial in disproving the phlogiston theory and advancing the understanding of chemical reactions. Lavoisier's experiments demonstrated that respiration is a slow form of combustion, which laid the groundwork for future studies in biochemistry and physiology. Chemical reactions and stoichiometry. Lavoisier's work on chemical reactions and stoichiometry helped to establish the concept of chemical equations and the quantitative study of chemical reactions. He introduced the idea that chemical reactions involve the rearrangement of atoms and molecules, and he developed methods for accurately measuring the quantities of reactants and products. This work provided the basis for the modern practice of stoichiometry, which is essential for understanding and predicting the outcomes of chemical reactions. Reforms in chemical education. Lavoisier was not only a pioneering scientist but also a passionate advocate for the reform of chemical education. He believed that chemistry should be taught as a rigorous and systematic science, with an emphasis on experimentation and empirical evidence. In 1789, he published Copyright de Chimie, Elementary Treatise of Chemistry, which is considered one of the first modern chemistry textbooks. This book presented a clear and systematic account of the principles of chemistry, including the law of conservation of mass, the identification of elements, and the nature of chemical reactions. It also included detailed descriptions of laboratory techniques and apparatus, making it an invaluable resource for students and researchers. Personal life and collaboration with Antoine Lavoisier. Antoine Lavoisier played a crucial role in her husband's scientific work. She was highly educated and fluent in multiple languages, which enabled her to translate important scientific texts into French. Her translations of works by British chemists Joseph Priestley and Henry Cavendish were particularly valuable to Lavoisier's research. Additionally, Antoine illustrated many of Lavoisier's experiments, providing detailed drawings that enhanced the clarity and impact of his publications. The Lavoisiers hosted regular scientific gatherings at their home, where they discussed their research with other leading scientists of the time. These gatherings fostered a collaborative environment that was instrumental in advancing the field of chemistry. Political involvement and the French Revolution. In addition to his scientific work, Lavoisier was involved in various political and administrative roles. As a member of the firm Copyright and Copyright Trail, he was responsible for collecting taxes, which made him a controversial figure during the French Revolution. Despite his efforts to improve public health and agriculture through his scientific work, his association with the unpopular tax system made him a target during the Revolution. Lavoisier was also a member of several important scientific and governmental bodies, including the Academy of Sciences and the Committee of Public Safety. He played a key role in the development of the metric system, which was adopted as the standard system of measurement in France during the Revolution. His contributions to public administration and scientific policy were significant, but they ultimately led to his downfall. Trial and execution. The political turmoil of the French Revolution had a profound impact on Lavoisier's life. In 1794, during the Reign of Terror, Lavoisier and his colleagues from the firm G.A. de Copyright N.A. de Copyright Rail were arrested and charged with treason. Despite his contributions to science and public service, Lavoisier's association with the tax collection system made him a target for revolutionary fervor. Lavoisier's trial was swift and politically motivated. On May 8, 1794, he was found guilty and sentenced to death by guillotine. His execution marked a tragic end to the life of one of the greatest scientific minds of the 18th century. Legend has it that the mathematician Joseph Louis Lagrange lamented, "It took them only an instant to cut off that head, but France may not produce another like it in a century." Legacy and impact. Antoine-Laurent Lavoisier's contributions to chemistry and science as a whole are immeasurable. His rigorous approach to experimentation, emphasis on empirical evidence, and systematic methods laid the foundation for modern chemistry. Lavoisier's work helped to transform chemistry from a speculative and alchemical practice into a quantitative and experimental science. His discoveries, including the law of conservation of mass, the identification of oxygen's role in combustion and respiration, and the development of chemical nomenclature, have had a lasting impact on the field. Lavoisier's principles continue to be taught in chemistry classes around the world, and his influence can be seen in the work of countless scientists who followed in his footsteps. Conclusion. Antoine-Laurent Lavoisier's life and work exemplify the power of scientific inquiry and the importance of empirical evidence. Despite the tragic end to his life, his legacy endures through the countless contributions he made to the field of chemistry. Lavoisier's story is a testament to the enduring impact of scientific discovery and the ways in which one individual's work can shape the course of history. Thank you for joining us on this journey through the life of Antoine-Laurent Lavoisier. We hope you found this biography inspiring and informative. Don't forget to like, share, and subscribe to our channel, Biography Zone, for more fascinating stories of history.